Hi, friends. Okay, so, sometimes you guys are like, hey, we want to hear what you're doing in school. Well, we're going to do that today, and you're going to regret that decision. So, today I had a test on circuits. So, we're going to learn all about them. So, there are four main parts to a circuit. You start with your power source, aka a battery of some sort. Then it goes to a resistor, an inductor, a capacitor, and then back out to the power source. That's the basic setup. So then resistors are measured in ohms, which are that stupid thing that looks like an omega, because it is an omega. And then the inductor is measured in henries, which is an H, which sounds like a person, but it's not. And then the capacitor is measured in farads, which is named after Faraday, I would assume, because he made it up, and scientists are very egocentric. And then the battery, as you are probably familiar with batteries, is measured in voltage. So this is what I'm doing in my differential equations class. So we're playing with circuits and we're seeing what happens, and so I'm going to see if I can thoroughly explain to you how circuits work and how you do math in like 5 minutes in covering everything that we've done in class for the last week and a half that I was tested on this morning. I saw Dean Huber this afternoon, and he said I nailed the circuits question. So, perfect timing. So, you have the voltage from A to B, so the voltage that goes into the resistor, the voltage from B to C that goes through the inductor, and the voltage from, I'm going the wrong direction, from C to D that goes through the capacitor, and then the voltage from the power source, and that all has to equal 0 because obviously when you put batteries in something and turn it on, the energy loops through. It does not make more and more and more energy. So if you add up all of the energy that your electronic is using, and you subtract out the amount that is being supplied from the power source, you should get 0, unless the world is exploding. So that magically you get this equation. So Q has to do with charge, as is labeled down here. This is so hard to do looking at the camera. So Q equals charge, and so you move the E of t over to the other side. I think that's kind of explanatory. If you add it to both sides, then it gets to the other side and it's now positive. The rest of that formula is just kind of magically happens. So there's a relationship between the charge and the capacitor. There's an inverse relationship there. There is the derivative of charge, which is current. There's a direct relationship between that and the amount of voltage coming from the resistor. And the derivative of current, we don't really give a name to, but there's a direct relationship with that and the amount of energy going through the inductor. Are you regretting this yet? Because I am. So fun times over here. So for funsies, this is the stuff that I do all day. So if you are given a RLC circuit with L of 1 Henry, an R value of 100 omega, and a C value of 0.002 Faradays, which is 1 over 500 Faradays, then you just plug all that stuff into the magical equation that we talked about over here. You just plug it all in, so this is so hard. So the 1 goes in there because it was L, and the 100 is the R, and it goes there, and the 1 over 500 goes in there, and it becomes a 500, and you can't see what I'm doing right now. So that happens. And you're all so bored and nobody's watching this video anymore, I guarantee, and this is so complicated. So that's the kind of stuff that happens, and then you have to factor it, which is where it says m squared plus 100m plus 500 equals 0. And then you have to use, my friend, the quadratic formula, negative b plus or minus radical b squared minus 4ac all over 2a. And that's what that looks like. And then you get that m is approximately negative 5 or negative 95. Then that is your Q sub C, and the C stands for, I'm forgetting, what the C stands for because I had a test and my brain is now fried. But so that's that, and then your Q sub P, the other part, you have to deal with the 12-volt battery. So you're going to guess that it's some constant, and then you're going to do some magical stuff, and then you're going to get 500A, because we said that Q sub P was a constant, and then the derivative of that is 0, and the derivative of that is 0. So you plug those back into this original equation, and you end up with 500A equals 12, and then you find that A is 12 over 500, and then your final equation for the charge is Q equals C1, some constant, times e to the negative 5x plus C2 e to the negative 95x plus that 12 over 500 that we found over there. And if we were given an initial condition, like at time 0, the charge is this, and at time 0, the current is this. So that would be how you would find what the C1 and the C2 were, and it's all a mess, and it's a lot of fun. Look at the pretty picture of the circuit. That's my favorite part, is drawing the pretty picture of the circuit, even though it's pretty unnecessary. So yeah, this is the fun times that I had at 8 o'clock this morning, taking this exam. Now that I've thoroughly bored you all with circuits, I hope you understand a little more. Let me know if you thought this was fun and informational, or if you'd never like to hear me talk about math ever again. Either one, totally fine. That's pretty much it. Other things going on in my actual life. I don't know that I have an actual life right now. I don't think I do. I don't think there's anything else going on in my life. Family weekend is in 2 weeks, so Grandma and Pop and Mom are coming. That shall be very interesting. Fun to have you all here. Interesting choir concert, whatever. Michael Schnack's insane. Yeah, that's pretty much it. I don't really have anything else going on right now. Oh, I got presents from ORS today. Look, and it's a little thing, and it opens, and it's got Post-it notes, and it's so cute. I love present day. So, I'm gonna stop talking now because I have nothing else to say, and I've bored you all with circuits. So, fun times. This is literally what I do Mondays, Wednesdays, and Fridays at 8 a.m. College, learning stuff. Okay, love you all. Okay, bye.